So little bit context to people who didn't join yesterday's session. So we covered a stamp pattern. So we recently discovered that there are these strategic design patterns concerning to microservices, which are interesting topics to understand many complex problems or many of the issues that we face in design, and we found those in our the microservices course that we were going through. So we thought of going in detail of these patterns. So out of these things, there is this playlist for cloud design patterns, and we will be going through for next 2 to 3 sessions, trying to cover all the important patterns. So for now, we will be going through anti-corruption layer, back end for front end, bulkhead, and cache side. And then once that is done, we might be going through like a couple of important ones, not all of them, but just a few of them which are important ones. To answer the question, if this is related to system design or not, this is not immediately related to system design problems that are being asked for basic beginner level interviews. But whenever like if you're doing it, if you're interviewing with Facebook companies like Facebook, Google, or Amazon, or any sort of big companies who have complex architecture, and if you are interviewing at senior level or higher level, any of the design consideration can involve discussion on issues, and discussion on some sort of solution that could help the scalability or some limitations. So we were initially trying to cover the microservices principle and all such design patterns on the same line, so that we will at least have some breadth of knowledge about how things work. And then we should better be able to figure out what how to solve those issues that we might encounter in system design interviews. Yeah, so let's start with anti-corruption layer. Anyone has any doubts or any uh, uh, yeah, Vani, I guess yeah, just wanted to tell you that we didn't cover much yesterday except this one pattern. Yeah, even Asim, you guys can have a look at this deployment stamp pattern.
Sure, Sagar. Thank you.
Yeah. Okay, so let's start with anti-corruption layer.
In this video, we are going to talk about anti-corruption layer pattern, or some people know it as ACL.
Sagar, we studied this right before.
Yeah, anti-corruption layer was there in microservices this thing course. Like I guess previous topic only we had anti-corruption layer pattern. So this video is new, I think. So we can fast forward through this.
Right, Deva, like even you are also clear with this anti-corruption, right? I think that Asim was there that day. I don't know who are there, like studied this one.
Yeah, but we just went through from that educative material. I mean, it talks about facade patterns.
No, we tested one video too.
Video too?
Yes, sir. Anyway, start.
Not sure.
Yeah, this is the one, I guess. 3 minutes video we just executed. The older another one. Anyway,
this is totally different video, Ani. The video I remember the video you are talking about. It was a different video altogether.
Okay, no
on
worries.
Anti-corruption layer only, but it was altogether different.
Yeah. Okay, no worries.
Hi everyone, my name is Hussain, and in this video we are going to talk about anti-corruption layer pattern, or some people know it as ACL pattern. And if we want to categorize where the ACL pattern should set, we'll see that it sets under 2 categories, design and implementation, because as we will see, this pattern contributes a lot in how you design and implement the integration between 2 systems. And also the operational excellence aspects, because it's going to make the operational parts easier for you if you follow this pattern. And the ACL pattern is a layer that tries to communicate between 2 different subsystems without making any corruption to any of them. This layer could be permanent layer or temporary layer, as we are going to see through the video. And it's good to mention that the ACL pattern is using adapter pattern and a facade pattern. You don't have to know these two patterns in details to continue watching this video, but it's good to know what other patterns ACL patterns depends on. Finally, our pattern, ACL pattern, is similar to Strangler pig pattern. Hopefully, we are going to make a video about it in future. Now let's consider this scenario. Let's assume we have a legacy banking system that consists of three main services: client service, cash service, and transaction service. And there is some communications between these services. And then we have decided that we want to migrate our legacy banking system to a new system. And we have selected the client service to start with. Now, when we implemented the client service in the new banking system, it still will require some communications with the other two services. Client service will still need to communicate with the transaction service as well as the cash service. Now let's assume that all services, either in the new system or in the legacy system, are RESTful services. It's going to make the communication between them really easy and straightforward because all of them are using the same REST protocol. Then our client service is going to implement its ORM that updates the database based on REST protocol. Now let's make it a little bit difficult. What's going to happen if our legacy system uses SOUP instead of REST? And still, our client service still needs to communicate with the transaction service and the cash service. So the only option for us now is to go ahead and update the client service and allow it to communicate with other SOAP services. So let's go ahead and add SOAP implementation that will allow the client service to communicate with the cash service and transaction service. Now, what if we have planned that our new banking system will be based on RESTful services? We didn't have any plan to include any SOAP implementation in here. And we found ourselves that we just needed to implement SOAP implementation in our new banking system to allow it to communicate with other legacy systems. So by adding this SOAP implementation here, we have corrupted the system architecture we have planned to do for the new banking system. And the corruption is in not something breaking feature or something is not working. The corruption in that we have added a new implementation for a certain technology, which is SOAP, that we don't really need in our new system. We just added it to allow it to communicate with other legacy systems. This is the corruption, and this is what the ACL pattern is trying to solve in system.
I guess I'm having slight trouble about understanding the corruption. Are you guys able to follow this thing?
Yeah, even it is confusing, right? The corruption means what, like a version control or?
Yeah, I guess compatibility issues, I feel, in terms of SOAP versus REST. Okay, let us maybe just try to scheme through it once again.
It still will require some communications with the other two services. Client service will still need to communicate with the transaction service as well as the cash service. Now let's assume that all services, either in the new system or in the legacy system, are RESTful services. It's going to make the communication between them really easy and straightforward because all of them are using the same REST protocol. Then our client service is going to implement its ORM that updates the database based on REST protocol. Now let's make it a little bit difficult. What's going to happen if our legacy system uses SOAP instead of REST? And still, our client service still needs to communicate with the transaction service and the cash service. So the only option for us now is to go ahead and update the client service and allow it to communicate with other SOAP services. So let's go ahead and add SOAP implementation that will allow the client service to communicate with the cash service and transaction service. Now, what if we have planned that our new banking system will be based on RESTful services? We didn't have any plan to include any SOAP implementation in here. And we found ourselves that we just needed to implement SOAP implementation in our new banking system to allow it to communicate with other legacy systems. So by adding this SOAP implementation here, we have corrupted the system architecture we have planned to do for the new banking system. And the corruption is in not something breaking feature or something is not working. The corruption in that we have added a new implementation for a certain technology, which is SOAP, that we don't really need in our new system.
Yeah, I guess it's clear now, right? he just explained it
It's a
about
business requirement kind of thing.
yes. So I'm actually I was expecting that SOAP might lead to some data access issues or domain model issues, but I guess looks like it is just that we are adding something which is unwanted and which might make our design complex.
Yeah, but I think the reason is the legacy system can accept only SOAP calls, right? So that's the reason. I think I understood that in the banking system they have the REST implementation, but the legacy system can understand only SOAP. So here what they are doing, they are writing some logic to convert the REST to SOAP, and then through the SOAP they are communicating to the banking system. So now we corrupted our banking system because one legacy system needs a SOAP button access.
Got it. Yeah. Any doubts, anyone else? Okay.
We just added it to allow it to communicate with other legacy systems. This is the corruption, and this is what the ACL pattern is trying to solve. Now let's clean this up and see how we can use the ACL to resolve this issue. So let's place ACL in between of the new system and the legacy system. And our client service is going to communicate with the anti-corruption layer, and the ACL is going to communicate with the cache service and in the transaction service. Now let's have a look and see what's inside the ACL that's going to facilitate the integration between the new system and the legacy system. First thing we have in here is an API. This API is a RESTful API, which is going to make it easy for the client service to communicate with this RESTful API, because this is pretty much the same protocol that the client service understands and using. Then we have a facade layer. This facade knows how to send SOAP request and receive a SOAP response, and how to deal with the SOAP services in our legacy system. And in between, we are going to add an adapter, which knows how to translate between these two protocols. And this is the value of the anti-corruption layer. We have allowed our new system to communicate with the old system without causing any corruption to any of these systems. And as we migrate other services from the legacy system to the new system, let's say we migrated the cache service to the new system. The communication between the client service and the cache services is going to be RESTful communication, because both of these services are RESTful services. And these services in our new system are going to use the ACL to communicate with the transaction service that is still sits within the legacy system. And as we migrate the transaction service to the new system and have all of our internal communication been done using RESTful protocol, then we will find that our new system doesn't need to communicate with the ACL anymore. And we can drop these links and get rid of the ACL altogether as well. And this is how to use the ACL to help us to do a multi-stage system migration from a legacy system to a new system. And in this case, we have used the ACL temporarily. And also we can use the ACL layer permanently between two systems if we have a legacy system and a new system and they need to communicate with each other. And in this case, the ACL is going to live as long as these two systems has a need to communicate with each other. So we can implement the ACL permanently or temporarily, depending on our situation. Now let's talk about what are the different options we have to deploy and host the ACL. And we have three options: either to have it in a standalone deployment or...
Any doubts, anyone so far? I guess the facade pattern part it should be clear, right? We went through that previously either. So I guess the use cases is what they have clearly mentioned here, which in like the previous video, I was not able to figure out the use case, but I guess in terms of deprecating old service and bringing up new service, this makes perfect sense. So from security point of view, either this makes sense because there could be some critical tier 0 service, tier 1 service, which we want to expose the architecture to outer world. In that cases, I guess we might bring in some layers or to abstractions in between. So I guess there are a couple of use cases that this pattern solves.
And host the...
Any doubts, anyone? Okay.
ACL. And we have three options: either to have it in a standalone deployment or hosted in the new system or in the legacy system. Now for the standalone style, pretty much similar to what we have seen before. We have a legacy system and a new system, and the ACL layer is going to be hosted in a separate container or service or whatever you like. And you can host the ACL on Azure Function or App Service or even AWS Lambda. Now let's see when you should consider using a standalone style deployment for your ACL. When you are doing a multi-stage system migration, pretty much similar to the examples that we have seen, or you want to build a permanent ACL between two systems, or when you have a certain requirement to have a specific scalability for your ACL layer and is going to scale away from the legacy system or the new system. And finally, you need to be aware of the extra cost that's going to be included when you host your ACL in a standalone container or service. Then moving to the second style of deployment, deploying our ACL in the new system. And you should consider using this style of deployment when you have a requirement to build a permanent communication with the legacy system. And you want to avoid paying the extra cost that's going to be included for the standalone style of deployment. And finally, if you have no control over the legacy system. Then finally, we have the last style of deployment where we can deploy our ACL in the legacy system. And you should consider use this style of deployment if you want to have a permanent communication with the legacy system and avoid paying extra cost for a standalone deployment. And also you have no control over the new system. Now let's talk about some considerations you need to keep in mind when using the ACL. First of all, latency. We are adding a new layer between two service calls, and that includes a proxy and adapter that translate between two protocols, and we should expect some latency to happen. However, you should aim to keep that latency as minimum as possible. Then moving to the complexity. It's true that by using the ACL, we have avoided to cause any corruption to our systems, but we have added more services. We have added a proxy service, adapter, and facade implementations. And also, if you are going to deploy your ACL in a standalone deployment, you are going to have more Azure functions or app services that you need to be aware of. Then moving to scalability. If you are going to host your ACL in a standalone deployment, it's going to be really easy for you to scale it as much as you like, because it's going to be in a separate Azure services. But you need to think through what would be the case if you host your ACL in a new system or in a legacy system, and you need to scale it as well. And this is a key point that will help you to decide what's the right deployment style for your ACL. Then let's move to multi-ACLs. If you remember in our example, we had two different technologies, SOAP and REST. And let's assume that we had a different MessageQ technologies as well. And what you should do is to implement a separate layer for the REST and SOAP communication and have a separate ACL for the MessageQ communications. You don't want to have all of these different technologies implemented in a single ACL, and you should consider have multi-ACL for this implementation. Also, you need to consider how you are going to monitor your ACL, especially if you are going to have a standalone style of deployment. Also, you need to be clear of the scope of your ACL, whether it's include or cover every single service in your system or just a certain amount of services. Finally, you need to consider whether you are going to have a permanent or temporary ACL. Now let's see when we should be using this pattern. As we've seen in the example, if you have a multi-stage system migration, you should consider using ACL. Also, if you have a multiple subsystems with different technologies, similar to our example, we had a REST service and SOAP service, and we built an ACL to allow the communication between them without making any corruption to any of these services. Also, when you have different messaging processing systems. Finally, when you shouldn't use this pattern. When you don't have a significant difference in the technologies between different systems. Looking at this example here, all of these are RESTful services, even though they are using different technologies for implementation. In this case, you should not use ACL pattern. Now we are coming to the end of this video. I hope now it's clear for you what is the anti-corruption pattern is about, when you should use it, when you shouldn't. I hope you enjoyed this video, and if you have any questions, please put it in the comments below, and thanks for watching.
Yeah.
Hi everyone, my name is Hussein.
Yeah, I guess that was quite self-explanatory video, right? Anyone, any doubts?
Hi.
Shall we move on to the next one?
Yeah, sure.
Hi everyone, my name is Hussein, and in this video we are going to talk about backends for frontends pattern. This pattern lies under design and implementation category of cloud design patterns. And this pattern is about creating a separate backend service to be consumed by a specific front-end application or interface. And we are going to see this in more details in a minute. Also, it's good to mention other similar or related patterns to the backends for frontends pattern. Related patterns are gateway aggregation pattern, gateway offloading pattern, and gateway routing pattern. Hopefully, we are going to make a video to talk about these patterns in future. And to help you to understand this pattern, let's consider this scenario. Let's assume that we have a web application that's been designed to work on desktop web browser. And we have a backend service. And of course, there is kind of communication is going to be required between the front end and the backend service. And the backend service could be anything like Azure App Service or Azure Functions App, or even AWS Lambda if you are more into AWS world. Then you have decided that you want to evolve your solution and implement a native mobile app for your solution. Be careful here, we are not talking about mobile web. We're talking about a native mobile app version of your solution. And since you have already done the backend service for your solution, then you are going to connect the mobile app to the backend service that you have already implemented. Then you decided you want to grow your solution and reach to more customers through different front ends, like Alexa, for example. And you decided to build a dedicated Alexa skill or Alexa app for your solution. And then you are going to connect the Alexa skill with the backend service of your solution. And for those who doesn't know what Alexa is a device developed by Amazon, similar to Google Home that's developed by Google. And these are voice-enabled devices that allows the customer to interact with these devices using their voice. However, some of these devices come with a screen to make the interaction with the user even better. So the user can still interact with these devices using their voice and touch interactions on the screen or scroll buttons on the device. And this is the new level of front ends that you need to be aware of when you design your solution. So we have a desktop or laptop, then we have a mobile or tablet devices, then we have voice-enabled devices like Alexa or Google Home. Also, we have a smartwatch. So it's always good to consider what different front ends needs to be implemented for your solution before you start the implementation process. Now let's get back to our solution. And let's say that the desktop version wants to display the full profile details, including name, date of birth, city, phone number, email address. However, the mobile version is less interested in all of this information and just wants to display username, date of birth, and phone number. While the Alexa skill just wants to display the first name of the user. Now let's look at the backend service and see what it's able to provide. As you can see here, the backend service is able to return the full profile details. So you might be asking, what is the big deal? We have the backend service that returns the full profile details, and then we have a different front end that's going to display different amount of information as required. And this is exactly the challenge. Because if we decided to make a change to one of the front ends, the chance is really high that you might cause disruption to other front ends. And the reason for this is because all of these front ends depends on one general backend service. And this is the challenge that the backends for front ends pattern is trying to solve. Now let's see how can we resolve this challenge. So we are going to slice the general backend service into multiple services: desktop backend service, mobile backend service, and Alexa backend service. And then we are going to connect the desktop front end with the desktop backend service, and the mobile front end with the mobile backend service, and the Alexa front end with the Alexa backend service. Now, the desktop backend service is going to return the full profile details that's exactly required to be displayed on the desktop front end of our solution, while the mobile backend service is going to return the amount of information that's exactly required to be displayed by the mobile front end, while the Alexa backend service is going to return just the first name that's required to use in the Alexa skill front end of the solution. Now, if we decided to make a change on the Alexa display and add more fields, then we can make updates to the Alexa backend service without worrying about making any disruption to other front ends of our solution. And this is the true value of the backends for front ends pattern. Now, let's say that our solution wants to transfer money somewhere. Then we are going to implement a transfer module in all of our backend services. So from one perspective, we have improved our solution by implementing backends for front ends pattern. But from the other side, we have violated the right principle: don't repeat yourself. And we have repeated the transfer module over and over across all of our backend services. And this is not the right way to do it. And the right way to do it is to pull out all of these transfer modules from the backend services and put them in a separate service. Let's call it transfer service. Then we are going to have a communications between the different backend services and the transfer services or any other common service. Now you might be asking, what should stay in the backend service and what should be moved to the transfer service? And the answer for this is whether it's a business logic or a client-specific logic. Client-specific logic is the logic that's specific to a particular front end. For example, Alexa backend service here is going to have the Alexa-specific logic that's required to run your solution on Alexa, similar to the mobile backend service and the desktop backend service. While the business logic will have the business rules or validations that needs to be applied across all of these backend services. And having this in mind, it will help you to determine what should stay on the backend service and what should be moved to other transfer service or common use service. Now let's talk about some considerations you need to keep in mind while using this pattern. First of all, the number of backend services. You need to be clear of how many front ends are required to be supported in your solution. And then you will get sense of how many backend services you will have to implement in your solution as well. Also, you need to decide whether to implement a backend for each front end or to have just a single backend for all front ends in your solution. As we have already seen before, in this situation, each front end is going to display different amount of information. Then it makes sense to have a separate backend service for each front end. However, if all of your front ends are going to display same amount of information, which is the full user profile, then it will make sense to have single backend service to be consumed from all of your front ends. Then you need to be aware of code duplication. While creating separate backend service for each front end, there is amount of code duplication is going to happen. However, you should aim to keep this as minimal as possible. Also, client-specific logic and business logic, as we have seen before, we should aim to have only client-specific logic stay in the backend service. Other business logic should be moved to other common services to be consumed in your solution. Then talking about development team responsibilities. Are you going to have each development team responsible for a backend service or making all development teams responsible for everything? That's depending on your operating model. Also, finally, the implementation efforts. In addition to the coding and development, you need to be aware of the CI/CD pipeline, deployment effort, debugging effort that you will have to do when implementing or creating multiple backend services for your solution. Now let's see when you should use this pattern. When you have a significant development overhead in a general backend service. As we've seen before, we have a single backend service to be consumed from different front ends. Each front end is going to display different amount of information. Then accordingly, we will have to do a lot of customization in the backend service to be able to serve these different front ends. And this is exactly when you should consider using this pattern. Also, when you want to optimize the backend for a specific front end or a specific client interface, also sometimes you might find that another language is better for the backend service for a certain or a specific front end, like Alexa presentation language. Now let's see when you shouldn't use this pattern. If your interfaces are making the same request to the backend, consider this scenario here. If all of your front ends are required to display the full profile details, then it doesn't make any sense to implement this pattern and have a separate service for each front end, as long as all of them is required to display the full profile details. And it will make more sense to implement a general backend service to be consumed from all front ends, as long as all of them are going to display the full profile details. Also, when you have only one interface in your interaction with the backend, if you have only a mobile app, then you don't need to implement this pattern. You don't have an Alexa skill, you don't have a desktop version or a smartwatch, just a mobile app, then you shouldn't use this pattern. Now we are coming to the end of this video. I hope now it's clear for you what the backends or frontends pattern is about, when you should.
Any doubts, anyone? I guess it was pretty straightforward, right?
Yes. Nothing much what we are doing other than that.
Yeah. Shall we move on to the next?
Sure.
Hi everyone, my name is Hussain, and in this video we are going to talk about the bulkhead pattern. Bulkhead pattern lies under reliability category of cloud design patterns. As we are going to see through this video, this pattern contributes a lot in improving the reliability of your solution. As the definition says, It's going to isolate different application components or elements and put them into isolated pools. So if one component or pool has failed, others will continue to function as usual. It's good to mention other related patterns to the bulkhead pattern. Related patterns are circuit breaker pattern, retry pattern, and throttling pattern. And in most cases, you will find yourself need to implement some of these patterns in your bulkhead pattern implementation. Now let's see from where the bulkhead name comes from. And it came from shipbuilding. Ships are not one big unit, as you may see from the outside. What's actually going on the inside is that they build the ships based on different sections, and they called it bulks. In the old days, when one of these bulks gets compromised or filled with water, water is going to leak to other bulks of the ship, ending up sending the whole ship to the deep water. Then a solution has been introduced to build a stronger barriers between the bulks, and they called it bulkheads. So if one of our bulks gets compromised or filled with water, the water is not going to be leaking to other bulks, and the ship can continue its journey. Bulkhead is still in use in maritime, in building ships, navy, submarines, and we are using the same concept to make sure if one of our services got compromised, it won't affect the full solution. Now let's get to the scenarios and see how can we implement this. Let's say we have three services, service A, service B, and service C. And some clients are sending requests to service C. And in order for service C to perform the client requests, service C has to call service B to get some data. And similarly, service B has to call service A to get some data as well. Now let's assume that service A has got compromised or become unavailable. Now we know for sure that service A will not be able to perform its function, and we are going to lose the part of data that service A was supposed to get. But someone might say, as we are implementing service-oriented architecture and we have our solution built in different services, we should be fine. We have only one service down, but other services are up and running. But unfortunately, this is not the case, because service B is continuously trying to reach to service A to get the data. And sooner or later, service B is going to run out of resources, because all of the service B resources are going to be exhausted, trying to reach to service A, which is not available anymore. So sooner or later, service B will not become available, as well as service A. And to give an example on this, let's assume that our services are built on Azure App Service. And if you have used Azure App Service,
So this is about tier 0, tier 1, tier 2 services, right?
Yeah, I mean, we can take it as like a multiple microservices.
Can you
Yeah.
comment on that?
We can consider that as like a 3 different microservices.
Yeah. So I guess so in previous
to implement it.
one or two topics, we were actually talking about some convention, right? Which one should be called as upstream service or which one should be called as downstream service, right?
Oh, yes. I think, yeah, the upstream and downstream, right?
Yeah. So this is about upstream and downstream, right? Customer and supplier pattern. This way, right?
That's correct. Yeah.
Yeah. So one thing we saw there is this line. Actually, I was looking for this. Upstream team can influence the success of downstream team. However, the downstream team cannot influence the success of upstream team, right?
Yeah.
So that should be like if this is an upstream, so this will influence this service, right? So in turn,
But
this will be downstream.
No, it is both, right? Like it is not the way. Even downstream is down means it is not influenced. It is influencing the upstream, right? Sorry.
Can you come again?
See here, A is the downstream service, right? B is the upstream service. Oh, okay. But what is the use if B is down?
Yeah, are we sure about that? I feel what they have mentioned here is that upstream can influence the success of downstream. However, downstream team cannot influence the success of upstream. So I feel this is upstream and this is downstream.
Yeah. So the context that they were explaining, right? The the influential things, right? That is applicable only for the contract. In the sense, like, let's say that those two systems needs to communicate. For example, there is a processing and then the order, right? So processing itself can work fine, but to get the order successful, processing should give all the information that order needs, right? So that's where, so when we think about the contract, like, for example, I mean, in their example, they mentioned like order and payment. Sorry. So order is the upstream and the payment is the downstream, right? Order itself can work fine because it just need to order. But to get the payment to be successful, order should pass all the relevant information that the payment needs, which is kind of a requirement perspective. That's where they were explaining, like, if the downstream to be successful, upstream should be in consensus. Like, they both the teams should interact and work with, make sure the contract is good. But here, this pattern that they're explaining, which is a bulkhead pattern, is like the maintenance perspective. Let's say we have two different, I mean, the contract, everything is good, but let's say the application is running, but after 1 month, maybe, one system or one microservice went down. How we would, how we can avoid this issue, because if we are not properly mitigating it, this can get into it can bring down the whole virtual machine or something. So that's how we can safeguard. That's the pattern that they're explaining. Like, it can, I mean, we can try in a way that there are some implementations for this bulkhead, which is, I think yesterday somebody mentioned that, like the Hystrix and all. It's one of the implementation provided by Netflix, which we can use that. What we can configure in a way that, hey, try 3 times. If it's not successful, then don't try after that. Something like that. We can. That's the idea for the bulkhead pattern. So let's say the service C received the call from the user and the service B is down. So the service C, what it can do, it can try a couple of times. I mean, however we are configuring, and then if it's still the service B is successful, then there's a fallback option. So the Hystrix provides a fallback option. So that
Fault tolerance, you mean to say fault tolerance?
No, not fault tolerance, fallback. Fallback is just nothing but the interface implementation. So what we say in the service C itself, we write, hey, service C, try to call service B these many times. If it is not working, I will give you one more method, call this method. So what it will do, the service C will try to call service B twice, or however we are defining in the configuration. If it is not successful, then what it will do, it will call a different method in that implementation.
Yeah, that is called fault tolerance.
Okay.
FAULT, fault.
Yeah, fault tolerance. Okay. That's correct. So the method that we write, we call it as a fallback method, but maybe I'm confused. It could, yeah. Default
Callback or fallback?
Fallback.
FALL or?
Yeah, fallback method.
Okay.
I mean, maybe it may be specific to Hystrix, but the general idea is like, if something, then what we can do in the fallback method, we can write some basic implementation in a way that you can return a response that, hey, D is down, I cannot do anything, so that the user will be graciously knowing that, okay, I tried to call service C, but I received some error that they couldn't reach out the payment service, so they are returning an error message. So they are receiving a proper maybe 200 or however they wanted to return the response code, they can handle it. Yeah.
So
Yes.
this very thing that you mentioned right now, right? For the fallback option, this is called as circuit breaker pattern.
Yeah, circuit breaker or fault tolerance, everything both same.
Yeah.
So it is. So I feel. I guess that definitely makes sense. But in context of circuit breaker pattern,
Maybe
now,
I was explaining the circuit breaker. I think maybe this could be a different one.
Yeah, I think the bulkhead pattern, they go for circuit breaker. I guess so in future. Like the answer for this might be that one.
So circuit breaker is different from bulkhead, or both of them are same?
We need to see, I guess, right, Sagar? Like bulkhead, as per the like he mentioned as an example, they are disconnecting, which is not exactly, we cannot say disconnecting. We can say in the software terminology, disconnecting with the fault service, right?
Yeah, exactly.
how to handle that later part?
Oh yeah, that handling is the one. I mean,
We have to check.
I'm thinking. I mean, we cannot do anything. It will try twice, and then it will return back. The service fee itself will have an implementation to respond back with a way, however we wanted to put the response entity back. Right? We can say like 200. Hey, I couldn't. Maybe we can put a small payload in a response saying that, hey, I could not successfully finish this job. This is the response code and this is the payload. Something like that, we can graciously finish it up. But one thing I think Sagar raised, I wanted to maybe make sure, like, is that the circuit breaker and the bulkhead are same, or, what is the exact difference between those that we may
I guess they are totally different, Deva. I guess the context that we are talking about, like the context in which circuit breaker is used is different. And here, I guess we are only trying to deal with importance of a service, like dealing with the scalability part of a service, because other services are dependent on that, right? So bulkhead is specifically talking about that. That's what I feel, that compared to circuit breaker, where we try to think about strategies and we divert our expected response into some fail closed or fail open mechanisms.
I think he might have told in future, like that video, if you see, he might have said the solution also.
Yeah, I feel so. Yeah, and I guess Hystrix you were talking about, right, Deva? This is one of the good article I shared in the group. I guess which is really good. I think you can have a look at this one.
Okay.
So here they have clearly mentioned about how to handle that, like all the fallback options, and I guess they have also given some way to create those fallback options.
Okay. Maybe, I think, yeah, my bad. I was explaining the circuit breaker, but I think what we are reviewing is totally different. Bulkhead, right?
Yeah. So I guess Hystrix command is something that I could see here. So in command pattern, I guess like Java OOP command pattern, we can select which response to return, right? The way we can respond to a single request. I guess that could be one of the way to deal with this thing. I guess we can go through the article later on to understand this better.
Yeah, sure.
The service that calls on A. And to give an example on this, let's assume that our services are built on Azure App Service. And if you have used the Azure App Service to implement a service that calls another service, you may come across SNAT port allocation or SNAT port exhaustion terms. And what it means that each Azure App Service has a defined set of SNAT ports that it can use to reach out to other services. Now back to our example. SNAT ports for service B is going to be fully allocated, try to reach to service A, which is not available anymore. The only thing that's going to release these SNAT ports is when the timeout has expired. And even though when it happens, it's going to be reallocated by the requests that service B is continuously sent to service A. So bottom line is these SNAT ports are going to be allocated at all times and service B is not going to be available. And similarly, service C is not going to be available as well. And this is the first scenario that we are talking about here. Now let's talk about a different scenario. Let's assume we have a service. Let's call it service X. And we have a different clients sending requests to service X. However, one of these clients is sending an overwhelming number of requests to service X, and other clients are sending a standard number of requests. What we are going to see that service X resources are going to be busy performing the requests coming from this particular client, and it's going to affect service X availability to perform the requests coming from other clients. And this is the second scenario that we are talking about here. One particular client is sending overwhelming number of requests that affects other clients to perform the requests. What we are going to do here is implement a connection pool in service C. This connection pool is going to be allocated a particular number of SNAT ports. And this connection pool is going to be dedicated for all communications with service B. And similarly, we are going to implement a connection pool in service B that's responsible for all communication with service A. And as well, we are going to allocate a particular number of SNAT ports for this connection pool. Now, when service A is done or becoming available, all of the SNAT ports being allocated in the service A connection pool are going to be allocated trying to reach to service A, which is not available anymore, leaving the rest of service B SNAT ports and resources free to perform other operations that service B needs to perform. So this is our bulkhead that stops the damage in this situation. Now let's see another example. Let's say that the external clients are sending requests to service A, as well as internal system calls coming from service B. And the external clients are sending an overwhelming number of requests to service A compared to the requests that service B is sending. And what's going to happen is that service A is going to be really busy to perform the requests coming from the external clients, and it might affect service A availability to perform the internal system calls coming from service B. And what we need to do in this situation is to implement a container that's dedicated to perform the requests coming from the external clients, and have another container that's dedicated to perform the internal system calls coming from service B. And when we receive an overwhelming number of requests from the external clients, we can scale the containers up as much as we like to perform these requests. Now let's take it to the next level. Let's say that the external clients are launching a DDoS attack on our service, and that attack has successfully passed through your security defenses and firewalls. And what's going to happen in here is that it's going to affect the container that's been dedicated to receive the external client requests, leaving the other container up and running to be able to receive the internal system calls coming from service B. This is how we can use the bulkhead to stop that damage and to allow service A to isolate different workloads coming from different clients. Now let's go to the second example. We have the different clients sending a different number of requests to service X, and I'm sure you will get it right. We will create different container for each client workload to make sure that they are going to be separate from each other. And if one client is sending overwhelming number of requests to service X, we can easily scale up the container that's been dedicated for that client and leaving other containers able to perform other clients' requests. And on the other side, if one of the clients is performing a DDoS attack against our service, it's going to affect only one container that's dedicated for that particular client, leaving other containers up and running to perform other client requests. This is how.
Yeah, I guess it makes sense now, right?
One is easy, okay. I didn't get like one, they said they're creating this pool, right? So as per the things, like if the service A is down, and what will happen to the service B pool? Like it releases that one. That's it, right?
Yeah. So I guess if service A is down, service B is down, so it will affect only the connection pool or only the containers that are serving the communication from B, right? And rest of the workload on A is still working. Like A might have Z, A might have X, A might have some other workloads where they have other containers serving other services that should remain unaffected. And if only like there is a connection pool which is dedicated to B, then that part will be affected only.
Got it. Got it.
Any other doubts? Okay.
How to use the bulkhead pattern to stop the damage in your solution. Now let's see some considerations you need to keep in mind when implementing this pattern. First of all, the level of isolation. How deep do you want to go in your isolation? Are you going to create a separate container for each client, or are you going to organize them differently? You need to combine the business requirement with the technical requirement in this area to make sure that you are putting the right level of isolation into your solution architecture. Also, I mentioned before that you may be able to use retry or circuit breaker or throttling patterns and combine them with the bulkhead pattern.
Yeah, I guess they did mention that finally.
Yeah, that's right.
Yeah. So I guess we have our answer, right? They are somewhat related. Just that here we are dealing it using connection pools, and in circuit breaker we might have some fallback mechanism to deal with the same issue, right?
Yeah.
And I guess the retry one, there is separate retry pattern either. I guess what you were mentioning about histories or in retrying, that could be a third different way of handling the problem.
Exactly. Maybe the retry is totally different, and the circuit breaker. Circuit breaker is just the fallback implementation, right?
Yes. Yes.
Retry may be totally different. I was combining both. That is
Yeah,
what
yeah.
I'm saying.
And
So,
throttling is about rate limiting, right? Where we
Yeah.
put rate limit on particular type of request based on particular parameters.
Yes. Yeah.
Vani, you were
so
saying.
what retry what you said, like you combine means retry means we are keeping some time slot, like the suffix time to retry that service, right? How we are doing it in a microservice.
Yeah, I guess the request deduplication we were studying about, right? So in those cases, we can have some timeouts. If we don't get response back, we will resend the request, and we might have some retry threshold, like we can have 5 times retry,
Mhm.
and the request could be duplicated 5 times and should be sent. And if we don't receive the response, we can just deny the response, or just fail the request.
Okay, trying fixed number of times, retrying fixed
Yeah.
number of times is what. Okay.
I guess we also have retry pattern in this playlist.
Mhm.
I guess that in that we will be able to better understand this.
So throttling pattern means like fixed service is fixed
Throttling is all about rate limiting. So
rate.
whatever
Okay.
we saw in rate limiting, that is about throttling.
Okay. Okay.
Yeah, I guess now this explains a lot of things, right, Deva? Even in system design, if we go to the queue, like designing a queue part, the video that we were watching, they were using circuit breaker, and they were also talking about fail safe and fault tolerance part, right?
Yeah.
And in other system design as well, these things will come into greater detail if it is something really complex design.
Yes. Yes. Yeah. One thing that I'm still not clear, like they were explaining the connection pools, right?
Uh-huh.
How that would work internally. I mean, how they would put the connection pools. For example, I mean, the service B connection pool is sitting in service C, right? So maybe I'm not sure like how the implementation would go. So that
So
the idea is like they don't want all the connections pools. I mean, they don't want all the resources to be stayed with service C, right? They wanted to have appropriate resources allocated to keep the service B and A running. That was their idea, right? So that they are allocating kind of a very less amount of resources to service C, so that if it overwhelmed the service C, it should try within that limited resource, and if that maxed out, then the service C will stop calling service B because the connection pool is maxed out for the given limit, right? Even though the virtual machine or the operating system level, it has so much resources available, but what we are doing, we are trying to minimize or put very less number of resource for the service C, because if it overwhelmed, it may not kill the operating system.
yes, and I guess somewhere on top of that, what you just mentioned, I guess he just mentioned about port exhaustion, right? And I guess pool size. So here, I guess he has explained about pool. The way I understood it is in pool, we allocate certain ports, and those ports can handle certain number of connections, right? So if we have a dedicated pool for whatever traffic coming in from B or B to C, so and we should be able to handle number of connections at a time. That thing we can call pool, and that could be a thread safe way. Like if the connection is already there, we can assume it as a thread, and just like other pooling mechanism we were going through, right? The buffer, I guess the bounded queue, bonded buffer, that is one of the perfect use case here. like for connection pooling, we can use those kind of buffer so that we at any particular time we maintain only 50 open connections, and rest of them we can make the other processes, extra processes waiting if they want to get hold on to the communication channel.
Okay, okay, got it. Yeah.
So this is a way, like we are instead of using up all the bandwidth for random request by any client, we are restricting the use of ports or use of bandwidth by particular clients. So like we can bind traffic to certain ports which will handle certain number of certain number of connections, and other clients could be bind to others, or other type of ports could be there which are public port where anyone can send the request.
Okay, okay, got it. Yeah.
Yeah, I guess here they have mentioned in detail about each public IP assigned as a front-end IP of your load balancer is given this number of ports for its backend pool member. Ports can't be shared with backend pool members for range of, yeah, I guess here they haven't mentioned that part. Yeah, maybe we can search about connection pooling and how it works.
It can use to read.
Yeah, and then the pool I was talking about here, they are binding the pool with the containers, right? So if we want to extend the pool, we can create extra containers, like we can spin up more container instances.
Yeah.
Also, I mentioned bit of isolation into your solution architecture. Also, I mentioned before that you may be able to use retry or circuit breaker or throttling patterns and combine them with the bulkhead pattern. In this example here, if we implemented the circuit breaker pattern in service B, that stop service B from calling or sending any more requests to service A as soon as service A becomes unavailable. This could be one of the ways to stop the damage as well. Also, if you are using Azure API management or functions app, you should be able to specify the throttling limit that each client is able to send to your service or your API. As we mentioned, the connection pool, you need to consider process or thread pool as well, also using separate VMs or container or processes for different workloads, and getting to the asynchronous communication, which is really interesting. If we use the message queue in between to loosely couple between service B and service A, then service B just sending the requests to the message queue, and it doesn't matter if service A is up or down. Service B, it's not going to be affected by the availability of service A, and this is one of the values of introducing the asynchronous communication in this kind of requests. Also, level of granularity ties well with the level of isolation, thinking of the business requirements and the technical requirements, finally getting to the monitoring to monitor all of these different partitions.
Are you aware about granularity? I guess this is also in context of scope. I guess granular scope or fine-grained scope are almost similar thing, right?
Yes.
Okay, yeah, ignore. Maybe we can check that later on.
Isolations you have defined for your solution. Now let's see when you should implement this pattern. When you want to isolate resources used to consume the backend services. Also, when you have a different tiers of consumers, critical, standard, and free, and you have to do some level of isolation between these tiers. Also, when you want to protect your application from cascading failure or dominoes effects. Now let's see when you shouldn't use this pattern. When it's not required to have that level of isolation between different consumer tiers, it's not a business requirement for you, then you shouldn't implement it. Also, you need to avoid the added complexity if it's not necessary. As I said before, you should always aim for simplicity over just following or implementing a particular pattern. Now we are coming to...
Yeah, I guess this is one of an important piece of information here. Shall we stop? I guess it's already 8:20.
Sure.
Yeah, sure.
So I guess we can go through rest of them similarly. Like if there is not much to discuss, I guess we can try to cover 3 or 4 in the next section as well.
Okay.
Yeah. So this is the one retry pattern, Vani, that we were talking about. This
Oh,
one is
got it. Yeah, all are there, right? Retry, throttling pattern.
valet key is also there.
Oh, I think all together only we are making this
Yeah.
using it most of the patterns, not one.
Yeah, choreography we have already covered. Choreography is also there.
We are using in our project. Deva, I am remembering you only. They put me in new project.
Okay. Yeah.
Guys help. So they are doing orchestration, right?
Yeah.
Yeah.
Yeah, orchestration. I'm just like learning that one. I don't know. I will put that one, the flow diagram with you guys. It's a stage. It might be the good what I can say. I don't know whatever we are using is right or wrong, but you can design that going.
If possible, Vani, maybe you can present that topic.
I am learning because today only they put me in that project.
Okay, sure, no problem.
Yeah, I'm like orchestration. They are saying like what is it? I will tell you. I am also getting used to the naming conventions there. Lot of.
Okay.
They are using Azure.
Okay.
Yeah, nowadays Azure, that's the one that we are also learning, right? I think, yeah, this one also Azure Cloud Design Patterns.
Okay. Yeah. Shall we stop here?
Yes. Yeah.
Okay. Thank you, everyone.
Yeah. Thank you all.
Thank you. Thank you.